Hello. Today, we are going to perform the second exploit, which is buffer overflow vulnerability exploit. So for this exploit, we are going to need two programs. So one is the exploit.c and another is the stack.c. So exploit.c is the one which would contain the shell code, which would run inject root shell, and then we would be getting the root access. And we have another program stack.c, which basically performs the buffer overflow, and the buffer which we are going to overflow is going to contain the exploit for injecting the shell. So if we look at the code here in exploit.c, we have the shell code, which basically translates into the uh, injecting the root shell. Then we have the main program here, which basically does create a buffer of so and so bytes. What we are basically doing is first we are going to fill the whole buffer with NOP instruction so that the whole buffer can be executed without any problem. Then we are going to calculate the stack pointer during the execution and also the offset where we have to insert our return address. And once we get the return address, we are going to insert this below in the stack buffer, so that on the execution we are going to hit this at some point of time, and then it's going to exit cleanly. And this is the shell code which we are going to write near the bottom of the stack, so that the whole of the buffer will be completed with the return instruction, NOP instruction, and ultimately the shell code. And then all of this is going to be written into a file called bad file, which will write the binary. And then we are going to write this into the buffer and then close the bad file, and which would complete the exploit. In stack.c, we have the buffer overflow where we are just going to have a buffer of simple 12 chars here, but we are going to overwrite it with a buffer of 517 bytes, which we get from the exploit. And on running it in this buff str, it's going to perform strcpy, which is unsafe copy, and that is going to actually inject the buffer which contains the shell code. Okay, let us take a look at how it is done. So before anything, we'll have to remove the kernel randomization. So basically this removes the ASLR, which is address space layout relocation. So this will ensure that all the addresses are in order. So we're going to where we perform echo 0 so that randomization is 0. It says permission denied, which we will need sudo access, and we run the same. Then we just check that again to see that it is done. Once that is done, we are going to uh, have the stack code with all the protection removed, which is basically no stack protection. Then we are going to have executable stack, and we are going to create an object file called stack, and then we are going to change the modification the permissions with the chmod 4755 stack. So basically 4755 will be a stack executable binary, so that is what the 4 will give, and 7 will be the root, and 5 and 5 will be the user and the group. So we are going to change the permission and then going to exit. After that, we are going to run the exploit. We are going to just do this one, and then we run exploit. So this is what it has calculated, the return address, and then this is going to be the current return address. So currently it has finished the exploit. Then we are going to run the stack code, and we see that the dollar symbol has changed to a hash symbol, which means it is root. We can confirm that. Who am I? We see that it is root. So we have been successful in performing buffer overflow and injecting shell code which enables us root access. That completes the buffer overflow exploit. Thank you.